Okay, hi everyone. Today we are going to proceed on from our laws of indices, and we're going to move on to two brand new concepts, namely the zero indices and also our negative indices. Alright, so let us take a look at our example here to build our concept. So from this example, we see a list of powers of 3. So we have 3 to the power of 4 all the way to 3 to the power of 1. Alright, and these are our numbers over here: 81, 27, 9, and 3. Alright, and before we move on, it will be good for you to try and list out some of the common powers of 2, common powers of 3, 4, and 5. So you do that all the way for 10. Alright, and we need to be familiar with numbers below 1000 so that it makes it easier for us to do some computation and some evaluation, right? And now back to this one over here. We have a list of numbers over here from 3 power 4 to 3 power 1. Alright, so as you can see down the list, the powers decrease from 4 to 3 to 2 to 1. Alright, and we have 81, 27, 9, and 3. So what is the trend along this these numbers over here? As the powers reduce, we see that from 81 to 27, it is actually divided by 3. Right, and as we reduce one more step down from power 3 to power 2, you can see that the action is also divided by 3. Same thing, power 2 to the power 1. Right, I have also a divide by 3 over here. Then what happens next is, now let me push this a bit further. Now power 4, power 3, power 2, power 1. So the next one down the trend would be power of 0. So here we have our first concept over here, power 0. Right, and if we follow the pattern over here, we also need to divide by 3. So 3 divided by 3 gives us 1. Right, so here we get our first result. 3 to the power of 0 is 1. Right, and in fact, if you try this with any other number, any number to the power of 0 is 1. Okay, except for 0. Right, 0 to the power of 0 is an indeterminate thing. So this one is a long story for another day. Alright, so for now, any non-zero number to the power of 0 will be equals to 1. Okay, so this is our first result over here. So let me state this above my head. So any number, right, to the power of 0 is equals to 1, with the exception of 0. Okay, now so this would be our few definitions that we need over here. Okay, the definition of a zero index. Okay. Okay, alright, so let's take a look at to push one more step down, alright? And we push it down one more step, alright? So power 4, power 3, power 2, power 1, power 0. The next one would be 3 to the power of negative 1. So what does this mean, alright? And as you can see, if we go down the trend and if we follow the pattern over here, 1 divided by 3 will give you 1/3. Alright, 1 divided by 3 will give you 1/3. So over here we can say that 3 to the power of negative 1 is equals to 1 over 3. So in the same way, a to the power of negative 1 will be equals to 1 over a. Right, 1 over itself, 1 over a. Same thing over here, a cannot be 0. Same condition. Right, because 1 divided by 0 is undefined. You get your math error over there. Right, and let's push one more step further. Right, we have 3 to the power of negative 2. Right, over here, if we divide by 3, okay, here I'm going to need some space over here. So I'm going to write this further, right? So 1 over 3 divided by 3 is going to give us 1 over 9. And we know that 9 is 3 square, so we can also rewrite it like this. And as you can see over here, right, let me move myself closer. Alright, over here. Alright, so here we have our power of negative 2. And over here at the denominator we have our power of 2. So what does the action mean when you have negative index? It just sends a number down to the denominator. Okay, so back to this over here, we push one more step further. 3 to the power of negative 3. Let's continue to see the trend. This is when you divide by 3, right? 1 over 9 divided by 3 is 1 over 27, and 27, as we know, is 3 cubed. Right, so can you see the relationship between the negative power and the actual number over there? Right, one more step. 3 to the power of negative 4 will be 1 over 81. Okay, and over here 81, as we've seen above, is 3 to the power of 4. Alright, so if we have n in general, right, a number to the power of negative n in general, this means that we're going to get that number in the denominator itself, alright, and we have our power over there, the power n over there. So a to the power of negative n will be equals to 1 over a to the power of n. Same thing, a cannot be 0. Okay, so what the negative number does is to send the whole thing down to the denominator. Okay, so these are our 3 new laws, or the 3 new definitions that we have for our 0 and negative indices. Okay, so at the same time, let us look at some examples first before I show you some interesting results. Okay, so alright. Okay, so we have practice now 6, and this would be our some of the examples for the 0 index. So let's practice a little bit with 0 index first and get used to this. Alright, so let's take a look. Question 1. Evaluate of to find the value of each of the following without using a calculator. So we have 2022 to the power of 0. This is obviously 1, so anything to the power of 0 is 1 based on our definition above, right? Okay, B, negative 8 to the power of 0 is also 1, right? C, okay, 3 and y to the power of 0, alright. This one we have to be a little bit careful. Now, if you want to take a closer look, this power of 0 belongs to y only, and not 3. So therefore we can only do this 3, and y to the power of 0 is 1. So this will be a very common mistake for everyone, where people mistaken the power to be the whole thing without the bracket. So for this case, it is y to the power of 0 and not 3y whole thing 0. Okay, so this one is 3 times 1, which will give us 3. And if you want to compare with the next one, we have 3y to the whole thing power 0. So if the entire thing power 0, the entire thing will be equals to 1. So there is a difference between with brackets and without brackets. Okay, alright, so what does this mean for 3? For question 3 is that it is just 3 times y to the power of 0. Okay, alright, so we look at number 2. Now for number 2, same thing. It is find the values of each of the following without using a calculator. Alright, so we have okay, let me move this. Okay, we have these things over here. A, right, 3 to the power of 0 times 3 to the power of 3 divided by 3 squared. Alright, so with this, I'm just going to apply the law of indices. There's no point doing all the calculation. I'm just going to use the law of indices to help us with this. So we have the same base, all are base 3. So I have 3 over here. I will have 0 times, I will have a plus 3. Divide means I will have minus 2. So over here, 0 plus 3 minus 2. So this will be 3 to the power of 1, which is also 3. Okay, for B, we have 3 to the power of 0 plus 3 to the power of 2. Now, please don't be fooled. For question A, it is times and divide. So when we have times and divide, we can combine our indices together. However, if we have plus and minuses, then we cannot combine our index. We have to add one by one. Alright, so for this instance, 3 to the power of 0 is 1, 3 squared is 9, so 1 plus 9 is 10. Okay, a bit different. Now let's take a look at what if we were to do careless mistakes and we have 3 to the power of 0 plus 2, which will give us 3 squared, and this is actually 9, right? Which is not the same as 10, like what we calculated earlier. So please beware of our careless mistake where if it's a plus over here, we cannot add our two powers together. Okay, now let us take a look at some special results that we have. Let me remove these questions over here. Okay, now let us explore a little bit on some special results. Okay, so here we have let's say if I have a, right? Wait, so if I have 1 over a to the power of negative n, right? 1 over a to the power of negative n. What does this mean for us is that we can write this as it's going to be a very big fraction though. It'll be 1 over 1 over a to the power of n. Okay, so you see this below. All right, a to the power of n. We can express this as a fraction on its own, right? And what we can do next is we can make use of our primary school notation, where we can write this as equals to 1 over means divide, 1 divided by 1 over a to the power of n. Alright, and we can apply our KCF to get 1 times a to the power of n divided by 1. Right? Keep, change, flip, and this is actually equals to a to the power of n on the right hand side. So if we see this thing over here, a to the power of negative n, it actually sends the thing upstairs. Okay, so with this we have our very first special result over here, where 1 over a to the power of negative n, okay, let me write this up here, 1 over a to the power of negative n will give us a to the power of n. Okay, so if you were to compare our definition and the special result over there, what does this mean? Whenever we have a negative index, it just sends it to the denominator, or we'll send it to the numerator. We just exchange it between upstairs and downstairs. Okay, now let us look at one more special result over here, where if we have two numbers a over b to the power of negative n, alright, so what does this mean is that we have 1 over a over b to the power of n based on our definition, right? The whole thing would be at our denominator. And what do we do with this is this will be equals to 1 divided by this thing over here. 1 divided by the denominator. Now, without further ado, let me distribute the n into the bracket. This is one of our laws of indices, and we apply our KCF, keep, change, flip. And we extract out the n according to the law. Okay, and last line we have something like this, b over a to the power of n. And let me copy the first line and show you what is going on over here. So over here we have a over b to the power of negative n, right? So what does it do to the fraction? It flips the fraction inside. So what does the negative index do? It actually does a 1 over something. It actually takes the reciprocal of the thing. Right? So what we are doing is we are looking for the reciprocal of the thing. So what is reciprocal means is just 1 over another thing, but the effect of 1 over something is just flipping the fraction. Okay, so whatever that is upstairs will go downstairs. Whatever that is, I'm not far enough. Let me go nearer. Okay, so whatever that's upstairs over here for a will go downstairs over here. okay, will go downstairs over here, and whatever that is downstairs, B, will actually go upstairs, right? So this is the use of our negative index. So let me add the result over here for you. Okay, the last result is A over B to the power of n would be equals to, power of negative n would be equals to, in red, B over A to the power of n, right? And let me remove this so that you can see. Alright, so without further ado, let us take a look at practice now 7. Okay, here we are, practice now 7 at page, oh dear, sorry, what page it is? 65. Hopefully it's not off. Oh dear, it is a bit off. Okay, alright, page 65. So practice now 7, page 65. And over here we have our, let me write down our few definitions. Okay, we are ready. Okay, so we have question 1a, right? Evaluate means find the value of each of the following. So we have 6 to the power negative 2, and what does this equal to? This actually equals to 1 over 6 square, right? And what is 1 over 6 square? It means 1 over 36. Okay, for B, negative 8 to the power of negative 1 means it is 1 over, right, negative 8 to the power of 1. So this will be equals to just negative 1 over 8, right, based on our definition right up there. C, okay, 4 over 5 to the power of negative 3. So what we are doing over here is we will make use of our special result earlier, right? This one above, right? So when we have a fraction, what do we do with a fraction? We swap the place. So same thing, when we over here, we can actually swap the places of our fractions, right? And we have our, the action of the negative is being used up over here. So we don't keep the negative there. We already use the negative, right? So what is 5 cubed? 5 cubed would be 1, 2, 5. 4 cubed would be 64. Right? So this will be answer for C. And for part D, we have 9 to the power of 0 divided by 1 over 9 to the power of negative 1. Alright, so this is going to be a little bit annoying, but bear with me. So 9 over 0 is 1. Okay, let me settle the powers first. So 1 over 9 to the power of negative 1. So what does this mean is whatever that is on top will go below, whatever is below that will go on top. So we just need to change the floor. So we use our negative power and we have 9 over 1. Okay, to the power of 1. So this would be 1 divided by 9, simply just like that. And what is 1 divided by 9? It is just 1 over 9, as simple as that. So this is how we evaluate using negative indices. And for number 2, we are going to apply a little bit of our laws of indices to determine this. Okay, so for question 2, we have okay, 2d whole thing to the power of 0 divided by d square and e power negative 4 to the power negative 1. Okay, so let us deal with this one by one. So 2d to the power of 0, the whole thing is just 1 divide by, alright, d square e power 4 power negative 1. So this means it will be 1 over the thing. So 1 over this thing. We're taking the reciprocal of this thing over here. Okay, so what do we have is 1, okay, keep, change, flip, right? So over here we have we have our d square and e to the power of negative 4, and we have already simplified this already, so we are done with this. Okay, Now, if the demand of the question is such that we want to leave our powers as positive powers, we may go one step further and look at this negative power 4 here. We can convert to a positive power by sending this to the denominator. So d square over e to the power of 4 also can, right? This is also acceptable. Okay, now let us push on, to practice now 8 at page 65. Alright, we now need to apply laws of indices together with our negative and 0 index. Alright, and everything will be the same. It's just that now we'll see negative numbers, now we'll see 0, and this shouldn't surprise us. Okay, so practice now 8. Question 1. Simplify each of the following, leaving your answer in positive index form. So our final answer, the powers must be a positive number. So like what we saw earlier is that if we have a negative number in the index, we will need to convert as a fraction to find the reciprocal of that thing. Okay, without further ado, question 1. Part A, we have a to the power of negative 1 times a to the power of 3 divided by a to the power of negative 2. And let us make use of our laws of indices over here. All the bases are the same, so I'm just going to like combine all my index. We have my negative 1, a plus 3, minus a negative 2. So as you can see, times and divide will be plus and minus the index respectively based on our law 1 and 2. So over here we have a to the power of negative 1 plus 3 plus 2, so it will be a power 4. Alright, part B. We have 16, d to the power of negative 2 and e, whole thing divided by 2 times d to the power of negative 1 and e cubed. Okay, so let us make use of law 5 or law 4 to distribute our the power to the denominator first, because we want to, like, based on BODMAS, we should settle the brackets first. So we have 2 cubed, right, which is 8. We have our d and e, and d power negative 3 and e power 3. Alright, we can distribute the 3 into the bracket. Alright, and don't forget your 2 to also need to have a power of 3. So over here we can make use of our laws of indices already, because it's just the top divided by the bottom. So 16 over 8 is 2, d power negative 2, right? So power negative 2 minus a power of negative 3. So top divide by bottom, so will be the negative 2 minus negative 3. Then for e, we have power 1 above, and at the bottom would be minus 3. Okay, and what we will get is over here we have 2 d to the power of 1 and e to the power of negative 2. So 2 and d are having positive powers, they'll be upstairs. E will have negative power, so e will be downstairs over there. Part C. Part C, we have our 18 g to the power of negative 6 divide by 3 and bracket g power negative 2 squared. So what do we do here is, okay, 18 g to the power of negative 6. I'm going to focus on my bracket first. So g to the power of negative 2 and squared. So I will have g to the power of negative 4, the law of indices number 3. So over here, I'm just going to do one by one. So 18 divided by 3 is 6. G, I have power negative 6. Divide will be minus power negative 4. So I have 6 g to the power of negative 2. And for my answer to in positive index form, I need to get rid of the negative for g. So over here, I have 6 g squared. Send this to the basement. Alright, find the reciprocal of this thing. Last question of the day, number 2. We need to simplify this annoying thing over here. So 6h squared divided by 2h to the power of negative 2 minus h times h to the power of 3 minus 4 over h to the negative 4. Extremely annoying. So let's take a look one by one. Alright, so what we can do is we can we'll need to apply BODMAS to some of these things over here. So whatever we don't have brackets, and we need to settle the order later. Orders first, but we need to settle orders first, but we have our division and multiply to focus. So we have our division, we have our multiplication, and we can settle this order now. So over here, let's take a look. 6 divided by 2 will be 3. H, we have 2 minus negative 2 as the power. Applying the law of index. Right, minus will be there. H times h cubed would be h 1 plus 3, applying our law of index. Next one, we have our 4 minus 4, and h to the power of negative 4. What does it mean? When we have a negative power, we can change the level to become the denominator or the numerator, correct? So whatever is at the bottom will come on top. So I will h power positive 4. So let me simplify this. We have 3h power 4 minus h power 4 minus 4h power 4. So over here we have like terms. Everything is h to the power of 4. So 3 minus 1 minus 4, I have negative 2h to the power of 4. So let's take a look at the index over here. Right, this index, is it a negative power? No, it's a positive power. We are fine. The negative in front is just negative of this thing. Okay. However, the negative power means it's the reciprocal of that term. So it's a bit different. Okay. So negative 2h power 4, the negative is just a negative 1 times of that, not a negative power. You must differentiate, yeah, between a negative and a negative coefficient and a negative power. Negative coefficient versus a negative power, like what we see in the question above. Alright, so this is the video for zero index and negative index, and let me just quickly flash through our few laws that we have over here. Okay, so we have our zero index right above, negative index, and two useful results for our negative index. So this ends our video for 3.3 negative indices. That's all, and have a good day ahead.